Alright, what's going on, everybody? So today we're gonna get through as much as domain 4 as we can today, and then we'll break for lunch, and then I'll see everyone on Sunday for testing. So let's go ahead and jump right into it. So starting at domain 4.1.1, given a scenario, apply common security techniques to computing resources. So we're gonna go over what a secure baseline is, different hardening targets that we would want to see in our enterprise. Okay, so establish secure baselines. So talk about a baseline. This is taking the English definition of it, right? So what are the basic things we're going to do for our operating systems, our images, or network infrastructure? So establishing secure baselines involves defining a standard set of security controls for systems, applications, or infrastructure. Now this could actually be like a baseline image where we hook up a brand new computer out of the box to the LAN and we image it using like a Windows deployment server, and we have a baseline image in there that may come with some pre-installed third-party software, some already hardened things like services and ports already turned off. So this creates consistency for our enterprise. It also lets us do benchmarking and assessment. This involves benchmarking against industry standards and performing risk assessments to understand the current security posture. So this is like looking at a security framework. Well, let's say an ISO 2700 framework, and looking at what they consider is a secure baseline for computers or operating systems or whatever systems we may have, and then using that to build our baselines in our organizations. So we have that kind of benchmark that we always use. So we can always go back to that resource and say, okay, this new system or this older system, is it with the current benchmark? Deploying secure baseline. So again, like I said, we could have that baseline image that's either in a brick, like a USB brick, or we're using Pixie to do it, our pre-execution environment with the Windows deployment server. We also have infrastructure as code. So we could have like PowerShell in our Windows environments that runs scripts that does our baseline hardening for us. We could have group policies that are managed per organizational unit if we're in like an on-prem Windows environment. We have Microsoft Intune for our cloud-based elements and our mobile device management. That's kind of the more modern version of it, Microsoft Intune. Maintaining the secure baselines. So this is just always monitoring that we have the best baseline for our organization. Meaning that if we have like Lenovo systems and a firmware update came out for those Lenovo systems to fix a vulnerability, we have to integrate that into our new baseline. So a continuous improvement, regularly reviewing and updating baselines for new security measures or responses to vulnerabilities. Okay, hardening targets. So we don't just harden computers. Now, this whole time I've talked about baselines and, operating systems being hardened. But we have other devices that are part of our enterprise. That could be mobile phones. It could be tablets. It could be IoT devices. So mobile devices, we want to harden them with a couple different ways. One, always have full disk encryption. Make your phones part of a patching system as well. They'll need patches and updates. We could have application control. So we can containerize things on our phone, and we can actually set a segmented part of the phone to only run corporate applications. We could also set application control on our corporate-owned devices that says, hey, you're not going to go to the regular Play Store. You're going to go to our corporate-owned Play Store, and that's the only place you can download applications. Now, all this stuff can be done through the use of mobile device management. That's just a software suite that allows you to do all these different hardening and security techniques for your mobile fleet of devices. Hardening workstations. I've beat this over your head a lot. Everything we do to harden a workstation. Change default credentials. Turn off ports and services that are unused or inherently vulnerable. Put host-based protections on them. Third-party software like antivirus, anti-malware, EDR, XDR. Ensure that you're doing permissions and IAM correctly. Doing the least privilege principle or principle of least privilege. Making sure you're setting the correct amount of permissions for whatever that workstation is doing or for whatever user is using that workstation. If it's part of a domain, make sure we have the correct group policy set on it. And that's from the kind of the server perspective, going into Active Directory and applying the group policy correctly. Making sure that that workstation is part of a patch management system. whatever system you may have, make sure it's part of those regular updates. Now let's get in some network devices. So switches, that's going to be really the first line, the first major infrastructure that a user may touch. So the typical network diagram would have a user, whether that be a laptop or a workstation, plugged into a switch, or maybe an access point plugged into that switch that's servicing Wi-Fi enabled devices. So we want to have secure access controls on that switch, utilizing VLANs for segmentation, disabling the unused ports on the switch. And when we say ports, we don't mean the actual protocols, we mean actual ports. So if interface 1 through 9 is open and we don't have that patched anywhere, no user going to be plugged into port 1 through 9, we want to turn those ports off. Implementing network access control using port security or 802.1x. Routers are going to use the same thing. We're going to have another network device that we're going to have to secure. So with routers, that's our connection to the WAN. So we're going to want to put strong encryption and ACLs on those connections, and also just doing regular updates to the routers as well. Cloud infrastructure. So the first line of defense when it comes to cloud infrastructure is protecting your console, protecting your portal, protecting access. So we need to have strong identity and access management, implementing strong IAM policies like multi-factor authentication, contextual awareness of our logins, using the principle of least privilege for any users that may access resources in our cloud, encrypting data wherever we can in our cloud, whether that be data at rest, data in use, hardening cloud-based resources, like if you're deploying a VM in the cloud or a container or any sort of clustering, web server cluster in the cloud, you need to harden that as well. Turn off port 23. Don't let unsecure ports be open on those resources. Just because they're in the cloud doesn't mean they're secure. Putting resources behind firewalls in the cloud or network security groups. Then also make sure that you're monitoring the cloud. A lot of times we get this idea like, oh, it's in the Google Cloud. They're monitoring it. They are, but they're monitoring it for their own purposes to see what to charge you. They're not monitoring it to protect your resources or to make sure your data is not getting breached. So make sure you have some sort of monitoring and logging set up in the cloud. Servers. Really what you could say for workstations, you can say for servers. So we're going to move on. Our OT though, when it comes to hardening our OT devices, they're there for a specific function to produce, to manufacture, whatever your OT environment is. So yes, the typical things we're going to do for hardening, like disable unused ports, unused services, of course. But a big one is physical security and having that isolated network for your ICS and SCADA systems. Embedded systems. This is going to be like your IoT devices. This is going to be the same thing as everything else. Minimizing your operating environment, turning off unused port services, scaling back that attack surface, having strong access control. That's physical as well. Don't forget, cybersecurity is also in the physical realm. Then firmware integrity. That's really what the target's going to be for those embedded systems, because they're not going to have a huge operating system. It's going to be purpose built. So we have to make sure our firmware still has integrity and that we're constantly updating our firmware. Real-time operating systems. So monitoring is big on this, making sure that we're monitoring it for its availability. That's part of our cybersecurity functions. Patch management, and again, access control. And we're going to move on. IoT devices, embedded systems, kind of the same. We harden them the exact same way. Okay, let's go ahead and do your quiz, guys. I'll give you a couple minutes, and then we'll come back and go over domain 4.1.2. Alright guys, let's go over domain 4.1.2 now. This is going to be wireless devices and mobile solutions. So this is just going to be going over the different types of wireless considerations. Down here we're going to go over different connection methods. I know it's crazy, but in Sec Plus they want you to know what cellular is. So let's go over it. So when we're installing Wi-Fi, there's a couple considerations. One, where we're putting the access point placement, making sure that we have full coverage, and making sure that we have good security on our Wi-Fi. We're using WPA2, WPA3. We can check coverage by doing site surveys and running heat maps to check signal strength in different coverage areas where we may have to put another access point or a stronger signal or a different type of antenna. This happens a lot when you're doing like non-standard build-outs. So a standard office, if it's like a 12-story office floor, obviously we know we're going to have to worry about wireless overlap because we're going to have access points on the first, the second floor, the third floor. But typically the way we put those access points on the ceiling, and they're radiating that signal down and around in an omnidirectional antenna, we're pretty safe when it comes to degradation via floor. But let's say we have a big campus network where we want Wi-Fi available from our users walking outside. We want their computers to be connected. We want to have roaming configured on our big campus. Then we might need some outdoor antennas that maybe require stronger signal, which requires more power. That won't just be PoE based. So sometimes we have those unique scenarios. But for the most part, a regular heat map will be fine. Now, as far as mobile solutions, so we have mobile device management, talked about in the previous slides that we're going to be using. This is how you administer and monitor mobile devices that are part of your corporate enterprise. You have to enroll the device in your MDM, just an app, enroll it. You get explicit permissions to that device then if you're enrolling in an MDM. This varies on how much control you have. It's a personal device. Maybe users obviously don't get full control. And then you get remote management of that device where you can select what apps are installed. You can do remote wipe. You can enforce full disk encryption. You can enforce stronger authentication into that phone, so maybe like a longer PIN plus a Face ID, like a quick multi-factor authentication on that phone. All right, the different deployment models. So if you're an organization that wants users to be able to use their phones to do work, we have a couple different deployment models we can use. And I'm not going to go over the pros and cons of each. We just got to understand them. So BYOD, that's bring your own device. This allows employees to use their personal devices for work. Corporate owned, personally enabled. This is when the company provides employees with company-owned devices that they can also use for personal use. So when they say personally enabled, that's like, oh yeah, you can download TikTok, you can download your Instagram, but this is a corporate phone, so it will be used for business. Choose your own device. And that's, by definition, what it means, guys, for COPE, but usually an organization, they're like, no, this is just for business, we're providing it. So probably not social media, depending on your job role. Obviously, if you're in marketing, it's different. Anyways, choose your own device. So this is a compromise between BYOD and COPE, or COPE. This is where employees choose from a list of pre-approved devices that are secured and managed by the organization. So with COPE, it's pretty much like, hey, we're buying 100 Galaxy S. I don't even know what Android has anymore. I don't like Android. But we're buying 100 Android phones, old bum-ass Android phones. So that's what you're going to have. Or we're buying the new iPhone 16, so that's what you're going to have. There's no choice. But choose your own device. This may be like a stipend. This may be like, hey, we're going to allow you to go buy a device. We'll pay the monthly stipend, and you're going to use it for work. Or it could be a list saying, hey, you go to the help desk, and you say, hey, I need to get a corporate-owned phone. They say, okay, this is our list. We have an Android or an iPhone. Which one do you want to use? Okay, different connection methods for our mobile solutions. So it's going to be cellular, Wi-Fi, or Bluetooth. I know, guys. Come on. Android, you got to stop with that stuff. Cellular. It offers wide coverage and better security, but can be subject to signal interception. Look, it's just, that's LTE, right? Cellular is a different connection method that, honestly, cellular is pretty secure. Like, unless our telecoms get hacked by China, which they did, right? Then cellular is pretty secure. So what I would say here is that if you have conversations that you don't want to you want end-to-end encryption, like use stuff like Signal. Use those third-party apps if you're doing it over cellular. Wi-Fi. That's what we all use. I'm not going to explain Wi-Fi to you as a connection method. And then Bluetooth, that's a short-range connection that sometimes need careful configuration. Okay, let's go ahead and do our quiz again. We'll just put 2 minutes up on this timer. It's a quick little lesson. All right, guys, let's go over the last section of domain 4.1, and then we'll take a little 10-minute break. So this is wireless security settings and application security. Okay, so wireless security. So we have different Wi-Fi protected access modes, WPA, WPA2, WPA3. Remember, WPA2 and 3 are the most up-to-date, and they're the most secure. They're not vulnerable. So if you're using WEP or WPA, that can be exploited. And when we say our Wi-Fi connections, we mean they can be exploited from user to the actual access point. That's what we're protecting. AAA and Radius. So AAA, authentication, authorization, and accounting, that describes protocols like Radius and TACX that are frameworks for authenticating, authorizing, and doing accounting for user access to network resources. Radius is typically used in our Wi-Fi deployments when we're doing WPA2 Enterprise or WPA3 Enterprise. So, what do we mean by enterprise? When you guys log into Wi-Fi at home, we call that WPA2 or 3/PSK, pre-shared key, meaning you just need a password. When we configure WPA Enterprise, we're using a username and password that's being authenticated against a authentication server. That would be a Radius or TACX server. Radius and TACX are going to be the protocols that send those username and passwords back and forth between user and server. So that's used in conjunction with our wireless networks to offer that sort of service. When we have users, they want to log into the Wi-Fi, we make them present their username and password. And then you have to make sure you're using the strongest cryptographic protocols when you're in your wireless settings. Okay, so same thing, use network segmentation with our wireless settings, like VLANs. Okay, application security. So application security involves measures and processes to protect applications from threats throughout their entire life cycle. So that's like if you have a web application, a website, like our Academy site, how do we protect it? What are some security measures? We do input validation. Ensure that all the input received by the application is validated to prevent common vulnerabilities like SQL injection or cross-site scripting. We could have secure cookies. Implementing secure cookies Handling practices include setting the secure and HTTP only flags. So pretty much that means, hey, we can set up on our HTTP connections saying only use HTTPS or only use these secure cookies. We can also have some code analysis. So before we deploy our application, we can have some senior devs come in, a change management session where we look through the source code and say, hey, do we have any well-known vulnerabilities in this code that we need to change? Code signing. So we can utilize code signing to guarantee the authenticity and integrity of software that's putting a digital signature on our source code that we may post to GitLab or GitHub or any Git repo. Patch management, of course. We want to make sure that we're patching our code if we have any third-party libraries in there that are vulnerable to update those libraries. Sandboxing. So sandboxing security technique where a separate isolated environment is used to run and test untrusted programs or code. That could be as simple as like a VM too. Then of course monitoring, right guys? Like I said, Security Plus tends to keep repeating itself. But yes, we want to monitor our systems, our applications for any anomalies to make sure that they're not getting exploited. Alright, let's go do our quiz. I'm going to put 10 minutes on the board and we'll come back at around 10:35 and continue on with Domain 4. All right, let's go ahead and get back into it. So now we're going to go over domain 4.2.1. Explain the security implications of proper hardware, software, and data asset management. It's a quick little slide deck here. The acquisition/procurement process. So the acquisition/procurement process is crucial for ensuring the security and compatibility of hardware, software, and data assets within an organization. So when we're going to go buy things, when we're going to seek out vendors, what is our process? Do we even have a process? How do we properly vet? Do we get on partner programs with these different vendors? How do we know that they're secure? Do they meet our compliance issues? We say compliance issues, like, does it meet compliance with our industry? So we want to do some risk assessment. So before acquisition, we want to do a thorough risk assessment. We want to do vendor evaluation, making sure that they have good security practices, that if they've had vulnerabilities in the past, how have they fixed them? Do we trust them? Vendors like CrowdStrike that have had major issues now in the past year, they're going to be constantly fighting this. When a new organization wants an EDR, XDR solution, they hear CrowdStrike, that's going to be a tainted reputation. Now, there's not all, there's competitors to it, but anyways. And then compatibility checks. Obviously, does that vendor integrate easily into your already established enterprise? Or if we go with this vendor, do we acquire this hardware? Are we going to do a whole reset to our network? Assignment and accounting. So assignment and accounting of assets involve the distribution of hardware, software, and data resources, along with maintaining accurate records. So now, who is the owner? Who's going to take ownership of this procurement process or whatever we order? Who's going to do the proper accounting? Who's going to properly classify it? And how do we classify our assets? How do we do the tracking of updates of our inventory? This is more like hardware. Typically, this can be done for software too. Like if we use a lot of third-party software applications that we pay monthly, we may want to track that. We want to track what kind of subscription we have. Do we have the premium, the enterprise subscription for these third-party applications that are necessary for our enterprise? Okay, and then monitoring, asset tracking, right? Kind of just going over that again. Disposal and decommissioning. But now this is a life cycle. Remember, this is a life cycle. So when we order a huge storage area network with 1 petabyte, what's our life cycle for the data remnants on there when we upgrade? What are we beholden to as far as compliance? If we're working at the courts and maybe we have files from the 1970s, do we have to keep that on a hard drive? Disposal and decommissioning has a lot to do with your industry and your compliance on how long we should have data. And then the proper disposal of it, also depends on your industry and different compliance. So you have different ways we can dispose of physical stuff. So sanitation. So data sanitation methods are degaussing, overriding, or encryption. This doesn't actually destroy a physical piece of hardware or storage. It just tries to get rid of all the data on there, all the ones and zeros. Then we have actual physical destruction. So it's assets that cannot be sanitized, like a solid state drive can't be degaussed. We just destroy it. We can either shred it, smash it, whatever the case may be. And then data retention. What kind of data retention policies we have? And again, that's beholden to our industry or whatever SOP you may have within your organization. Okay, quiz time. Let's go ahead and do that. I'll put 2 minutes up on this board. Alright, sorry about that. Let's go ahead and continue. So now we're going to go over domain 4.3.1. Explain the security implications of proper hardware, software, and data assets management with identification methods. So different identification methods we have in our toolkit and in our enterprises. So vulnerability scans. So vulnerability scanning is an automated process to proactively identify security weaknesses in network systems and applications. So I kind of showed you guys this when we did an Nmap scan. These vulnerability scans, though, are a little bit more deep than that. They can scan for any actual known vulnerabilities, like any CVEs that are out there. They can do deep scans into operating systems. They can do network scans. We can have scans that have some privilege on there. So they're run from like an admin account. And they can check third-party software. Okay, application security. This focuses on identifying, fixing, and enhancing the security of apps by finding, fixing, preventing vulnerabilities. So how do we identify vulnerabilities in our applications? We have analysis. We have different types of analysis. We have static analysis. This examines the application's code to detect vulnerabilities without running the program. That pretty much just means looking at the source code. Combing through the actual source code before it's in a runtime environment. Then we have dynamic analysis. So that's where we deploy the code, not necessarily in a production environment, maybe in our test environment, our sandbox environment, and we start doing dynamic tests on it. So it's trying to do SQL injections, cross-site scripting attacks, doing like bandwidth testing on it, trying to overload the system, right? Stress testing it. That's the word I was looking for. Stress testing a system. Okay, a threat feed. So threat feeds provide real-time information about potential threats and vulnerabilities from various sources. So we have OSINT threat feeds. This is publicly available information. We have proprietary or third-party threat feeds. We have information sharing organizations. So this is the exchange of threat information among trusted members. This is going to be things like Taxi or Styx, kind of like an ecosystem for sharing threats, or it could be from a vendor like Cisco has their Cisco Talos. Penetration testing. So penetration testing simulates cyber attacks on systems, applications, or entire infrastructures to identify and exploit vulnerabilities. This is a paid-for service where we have different types of penetration testing. We have black box, gray box, and white box. All have their own purpose. With a black box test, that's penetration testing exactly how a hacker would see it, with no prior information, no insider information about the enterprise. We have a gray box test. That's going to be where we have some information about the enterprise. So we're working with the company. Maybe they give us some IP addressing, some of the operating systems they use. It's a gray box test with partially known information. Then a white box test. That can be a couple different ways, but essentially you have access to the enterprise. So they let you come sit. They let you put a computer in their office, connect to the Wi-Fi, and you start doing like Nmap scans, whatever the case may be. Maybe they give you full admin permissions, which kind of be a weak test, right? If you just have keys to everything, then of course it's going to look vulnerable. But that's what a white box test is. Known environment. You have a known environment of what kind of operating system, devices, and network you're on, and you're trying to penetrate, do a penetration test from inside the enterprise. Okay, responsibility disclosure program. So this is just like bug bounties. That's what you're going to hear online. CompTIA decided to go with this term in the exam objectives. But a bug bounty program. This offers money for any external individuals that report vulnerabilities on your systems. So this is structured reporting, provides a clear and ethical path for reporting vulnerabilities. And yeah, you get paid for identifying vulnerabilities in a system. Okay, system/process audits. So this is having a third party coming in and auditing your environment. And they can either do one of two things. One, give you a certification saying, yes, you have good security controls and measures. Or A, they can just give you a report of what you're doing well, what you're not doing well, and have suggestions for you. The most common audit you're going to see is a SOC audit, a SOC Type 2 audit, which gives an opinion on your security controls and also kind of verifies that at least you're proactive in protecting your network or your enterprise. All right, let's go ahead and do the quiz. I'm going to put another 2 minutes up on the board. We're on domain 4.3.1. All right, now let's go over analysis. Okay, so different analysis of security vulnerabilities or if we've been exploited. So the confirmation phase involves verifying identified vulnerabilities to ensure they are genuine and not false indicators. So we're talking about in our enterprises when we're scanning, we're monitoring. How do we know that something is real, essentially? How do we know that... Let me bring this up. Sorry about that. How do we know that it's not a false flag or it is truly malware, it is a true vulnerability? So we have these different flags. We have false positives. So this is identifying, dismissing alerts that incorrectly indicate a vulnerability. So false positives is pretty easy to understand. We have false negatives. So it's saying that ensuring that no actual vulnerabilities are overlooked or missed during analysis. We have true positives. So this is not necessarily what we want, but if we're going to get an alert, we want it to at least be a true positive. A true negative is no rule matched and no attack present. So false negatives, this is what we don't want, right? So this is when we're not getting alerted, and then through our own log diving or analysis, we see that there may be an attack present. So our systems didn't alert us properly. So we want to ensure that we're not getting false negatives. We want to fine tune our systems to only show us true positives and not miss anything. But we don't want them too sensitive where we're getting overloaded with a bunch of false positives. So it's a very delicate system we want to do when it comes to analysis. Prioritizing. So we want to prioritize vulnerabilities. This is crucial for effective resource allocation and risk management. So this is our severity assessment. I've kind of talked about this before when you have different severity types and levels and how you respond to it. So we do have a common scoring system for well-known vulnerabilities. So it's called the CVSS, the Common Vulnerability Scoring System. This is going to provide a standardized framework for rating the severity of security vulnerabilities that gives us consistent and clear communication. So we have the CVSS version 3.0. I think there's a version 4 out as well. Let me look this up real quick. Yeah, there is a version 4 as well. So they constantly upgrade it. So you can see here. NIST from NIST. Common Vulnerability Scoring System Calculator. So version 4 wasn't out when this version of Sec Plus came out, so that's why we don't have it on the slides. But you can see it's just a calculation of a vulnerability. And obviously with 10 being the highest, 0.1 being the lowest, and that's a good way to prioritize it within your organization on whether or not you should patch something or whatever the case may be. Okay, let me bring this up. And then CVE, so Common Vulnerability Enumeration. So CVE is a reference method for publicly known information and security vulnerabilities and exposures. So this is just the CVE number that you get. So it has a unique identifier and a standardized description for all these known vulnerabilities. It gives us a clear and consistent way as an industry to identify cybersecurity threats. Okay, vulnerability classification. So classifying vulnerabilities helps in understanding their nature, potential impact, and required approach for mitigation. So type of vulnerability, we have different categories. So one of the good frameworks we can use, I'm going to show you guys, is the MITRE ATT&CK framework. This is one of those skills that, like as a cybersecurity professional, not really a skill, but just knowing about it can help. Let me minimize this. So this is the MITRE ATT&CK framework here. So this is a matrix that can help us put in a category the type of vulnerability we may have. This is the attack matrix for the enterprise. So this is like our IT systems. This is a well-known open source framework that is used, that cybersecurity professionals use to properly categorize. So you can see if they're stealing credentials, getting credential access. And it's a new vulnerability, we can put it in this category of credential access. And then we have little write-ups about it here. So that is the MITRE ATT&CK framework. Okay, the exposure factor. The exposure factor quantifies the potential loss or damage that a vulnerability could cause if exploited aiding in risk assessment. So this is saying, what is it going to cost us, right? What's it going to cost us as an organization, or how much is it going to cost us to fix that individual device that's been exposed or exploited? Environmental variables. So environmental variables consider the specific context conditions under which a vulnerability exists, influencing its severity and priority. So if we have an older system that is kind of segmented, isolated from the enterprise, that doesn't have important data on there, maybe just we haven't destroyed it yet, we haven't decommissioned it yet, and it gets exploited, and we have it isolated and it can't propagate throughout the network, in that environment, we're not rushing the whole team and, setting up PR teams and marketing teams to talk to the public about it, right? So that in that kind of environment, we take different steps to address that vulnerability or that exposure. Industry and organizational impact. So if we have a data breach that makes us non-compliant, like we have credit card information that's now on the dark web from us, that's going to affect how we respond in our certain analysis. Does this ruin our reputation and trust? Are we a cybersecurity provider? So like Okta, they're an authentication service. They recently had a cybersecurity incident, and they're a cybersecurity provider. So obviously that's going to affect their trust with all the different customers they have. Risk tolerance. So risk tolerance defines the level of risk an organization is willing to accept. This is also sometimes referred to as risk appetite, which establishes the degree of risk acceptable to an organization's objectives and operations. So your risk appetite or tolerance really does affect how much the importance of cybersecurity in your organization, how much resources are allocated to it, i.e. money, right? All right, let's go ahead and do our quiz. We're going to take another 10-minute break. I want to give my voice a rest. We're at domain 4.3.2. Okay, let's go ahead and continue. So now we're going to go over vulnerability response and validation of remediation. So how to respond to vulnerabilities? We have patching. So we've talked about patching over and over and over again, but this involves applying updates to software or systems to correct security vulnerabilities and improve functionality. Insurance. So we can do some risk transference here. So we can have cybersecurity insurance as one of our responses to a data breach or vulnerability. Segmentation. So segmentation involves dividing the network into separate segments to contain and isolate potential security breaches. We do this by restricting lateral movement, implementing VLANs, microsegmentation, things like that. Compensating controls. So we have legacy devices where we can't actually mitigate the entire risk. We can't update. We can't patch. We can put in compensating controls. Things like firewall rules, host-based intrusion detection and prevention systems. This helps us do some mitigation, but not complete mitigation, right? Because if we have a vulnerability on a legacy system, we can't patch it. So no matter what, it can't be exploited. We can compensate for it in other areas like isolation, segmentation, putting firewall rules, putting those host-based security measures on there. Exceptions and exemptions. So exceptions and exemptions are acknowledgments of deviations from standard security policies. This is like an exception to policy where maybe our admin account, we don't need a token because we put in there a good justification saying, hey, we have certain applications that can't do X.59 certificates as authentication. So we need an exception to that standard security policy, and I need to run my admin account with username and password. Rescanning. So this is just reevaluating. This is just, okay, we did our vulnerability scans every Friday, or maybe it's bi-weekly, but because of some, more security risks or things are happening out there in the world where we notice a high amount of DDoS attacks, we want to do some rescanning. And then audit. Obviously, we want to do some audits. These are formal examinations to ensure that security measures and controls are properly implemented and effective in mitigating identified risks. We've already talked about those external audits. Verification. So verification involves a series of checks and tests to ensure that remediation measures effectively eliminate or mitigate the identified vulnerabilities. And then, of course, reporting. So reporting involves documenting and communicating the findings, actions, and outcomes of the vulnerability management process to relevant stakeholders. So this is, hey, we found a vulnerability. Here's the steps we're doing or that we have done. And now we have to inform the stakeholders. So in an organization, stakeholders is really anyone that has a vested interest in that company succeeding. But really what we care about is our bosses, right? Making sure that the people that write our paychecks are happy and that they're well informed. Okay, let's go ahead and do the last quiz for domain 4.3. Let's go ahead and put a timer up. Okay, now let's go over domain 4.4.1, explain security, alerting, and monitoring concepts and tools. So we're going to go over monitoring, computing resources, and different activities. So monitoring compute resources. So compute resources, that's going to be our RAM, our CPU, and really like virtual machines or our servers. So monitoring computing resources is crucial for maintaining security and operational efficiency. It involves the continuous observation of systems, applications, and infrastructure to identify and respond to potential issues or threats. So what are we talking about here? We have CPU spikes. That's a compute resource that we're monitoring, our CPU. If we see a general spike that deviates from the normal baseline behavior, we want to monitor that. Our entire infrastructure, so physical and virtual network components, we want to monitor those. We want to monitor applications. That's part of a compute resource or offering as well. Log aggregation. So we want to centralize the storage of our logs and then implement some sort of system to index and quickly search against those logs. I've talked about this being a SIEM or SIEM, S-I-E-M. This does log aggregation. So this is foundational in security alerting and monitoring. Then the actual alerting. We set up the alerting. As the administrator, we want to set up how we get alerted and when we get alerted. So I've talked about this again. For some of my guys that are in my in-person class watching this, like I said, Security Plus starts to kind of repeat itself a little bit. So I'm kind of like sound like a dead horse, like damn, he's talked about this, but that's because fundamentals of cybersecurity don't change no matter how you talk about them. Alerting is always a part of cybersecurity, and the systems we use to monitor, to do vulnerability scans, to be proactive, to make sure we're not getting actively exploited. We want to set up an alerting system that works for us. So for Microsoft Teams, maybe just informational alerts goes to a junk box in our Microsoft Teams, or maybe to our email. If it's very sensitive, it's a severity score of 1, which means we have critical failure. We want to make sure that we're getting alerted from phone call, email, text message. So we want to customize our types of alerting. And then scanning. This is the proactive examination of systems, networks, and applications. We have all different types of scanning. We have active and passive scanning, where active scanning is actually touching the system, meaning we're getting on that system, scanning the files, and reporting back to whatever kind of anti-malware, antivirus, or vulnerability scanning system we have. Then we have passive scanning, where passive scanning maybe is just doing like Nmap scans, saying, oh, okay, what ports, what protocols are open. Then reporting. So what kind of trend analysis, what kind of performance metrics do we want to report on? Because reporting is only as good as the people you're reporting it to. So if we're a SOC analyst, we're reporting this to like a management, we want to say, hey, we think that these performance metrics are important because this may indicate some sort of data exfiltration. That's going to be important. Our documentation. So if an incident does happen and we have to do incident response, or if we notice some irregularities, we want to document that properly in our reporting. And then archiving. So how long do we hold on to historical information? So do we hold on to it? A, for how long? How do we store it? And then how do we secure the storage of that archive data? Because archive data can still be sensitive information that we don't want to just leave wide open to all of our users or the general public. And then validation. So alert response and remediation / validation are critical activities in the incident response process. So let's go over some of these. Quarantining. This involves isolating affected systems or components to prevent the spread of security threats. So that's like stopping worms or stopping potential exploit from pivoting or doing lateral movement. Alert tuning. So this is the process of adjusting our alerting parameters to reduce false positives and ensure the relevance of notifications. Incident analysis. So this requires analyzing the security incident to understand its impact, scope, and method of attack. So look at the impact. Sometimes this could be referring to a financial impact or reputational impact. And then the scope is, what did it really affect? Yes, it may have affected that server. Maybe a server went down from this exploit. But now what's the second and third order effects of this? Do we have to go on a PR run? Do we have to work with a marketing team to earn back trust in the public depending on what kind of breach it was. All right, let's go ahead and do our quiz. So we're on domain 4.4.1. All right, domain 4.4.2. Now let's go over the different tools we have for alerting and monitoring. So SCAP, Security Content Automation Protocol. This is a suite of standards for automating the management, security settings, and vulnerability management. So this is going to provide standardized methods for enumerating vulnerabilities and security configuration. This is an open source project. DISA actually manages SCAP, and Red Hat Linux also manages a version of SCAP as well that we can use. And this is just helps us automate hardening, essentially. It helps us automate hardening our devices. Okay, different benchmarks. So benchmarks are standard points of reference used to compare current security performance against best practices or industry standards. So again, this could be like an industry thing. So if we're going off different benchmarks for the finance industry, where do we sit compared to like competitors or really just to our other contemporaries? So guidance and recommendations. So this provides actionable recommendations for improving security based on comparisons with the benchmarks. Agent versus agentless. So agent-based scanning or monitoring means it lives on the actual system and it reports back to a centralized server, whereas agentless means we're just connecting. We're just connecting to a server or connecting to a resource to actually scan it and do our monitoring, but the actual compute resource is not being used on agentless on the individual device. Our SIM or SIME. So this is what I've been harping about. So security information event management. These tool provides real-time analysis of security alerts generated by applications and network hardware. Really what SIME does though, it does centralized log aggregation. And then it can do event correlation from that big data being collected. So it allows us to build dashboards that do real-time monitoring. It allows us to enable a large learning model, a machine learning to do event correlation. And it helps us with our reporting. Like I said, we use SIM, or Splunk, the major SIM or SIM provider, to help us with our upgrades of all of our Windows machines. Antivirus. So antivirus software is a fundamental security tool designed to detect, prevent, and remove malware and other malicious software. So antivirus works with, the scanning works two major ways. Either signature-based, that relies on a historical database of confirmed malware signatures that then we can just scan against, or heuristic analysis, which this involves machine learning and advanced algorithms to detect like a zero-day attack which, it really what it does is it creates a baseline and then it detects anomalies against that baseline and then alerts us about it. So that's heuristic-based analysis. It's based on behavior of that system and how a virus may or should act. DLP, so data loss prevention. This is a tool designed to detect and prevent data breaches. So data loss prevention is the software tool or suite that we use to prevent data exfiltration. So DLP works by us classifying the data. So if we don't want like PII, personally identifiable information, being exfiltrated, in our DLP system, we could say, hey, look for these common text characterizations. So if it looks like a social security number, alert us or stop that from leaving our network. So it identifies data. It looks at the different data classifications that we want to prevent from being exfiltrated. SNMP, the Simple Network Management Protocol. So SNMP is a protocol that we can use to monitor and gather information about network infrastructure. And SNMP traps are messages sent from our managed nodes to our SNMP server to alert us of any anomalies or just general health information and telemetry about that device. So this is for our network infrastructure. We use SNMP to kind of map out and look at the health of our system, our links, and kind of build a nice little network diagram for ourselves using the SNMP protocol. NetFlow. So NetFlow is a network protocol designed for collecting IP-based traffic and determining top talkers, determining where that information is going. I showed you guys this in my Unify router, my Ubiquity router, where we saw all the different websites, different applications that our users were going to, and how much bandwidth they were using. So NetFlow is the actual technology behind that enables this. And then we have vulnerability scanners. We've talked about that a lot today, so I'm going to skip. Okay, let's go ahead and do our quiz for domain 4.4.2. And then let's go ahead and take a 10-minute break. I want to give my voice a rest. But yeah, we'll come back at 11:45.